Hi everyone. So I am Ekaleva Abhishek, studying in IITG, and I am from Cohort 1. This is my second project and trimester 8. Let me quickly start with my project. So my project name is Network Failure Prediction. With using machine learning, I have done this project. Let me show. In this explanation, I will focus mainly on the technical implementation, the logic behind the code, and the decisions taken while building this project. Problem statement. In real world networking environments, failures such as high CPU utilization, memory usage, packet drops, interface errors, and etc., like uptime and latencies, can lead to network downtime. So the major challenge in that most of the time we react after failure occurs. So here the goal of this project is to predict before any impact creates using the machine learning. So I have created the data set where with the synthetic data set using Python. So I generated this generate data set with 10,000 rows of data using NumPy, as you could see here. Each row represents the state of a network device. The feature included are CPU usage, memory usage, packet drops, interface errors, uptime days, latency, bandwidth utilization, temperature, CRC errors. I used nprandom.seed42 to ensure reproducibility. Instead of randomly assigning failure labels, I created a risk based scoring system. For example, in CPU usage 85, like if CPU usage is greater than 85, I increase the risk score by 2. If it is between 70 and 85, I increase it by 1. As you could see here, risk score plus 2, this is plus 1. Similarly, I applied logic for memory usage, packet drops, interface errors. This is important because it introduces real world networking behavior into the dataset. I also added additional factors like high latency, temperature, CRC errors, uptime days, risk score. Sorry, risk score. It's different. So, for example, if I take a risk score greater than 8, greater than or equal to 8, failure probability is 95%. And if risk score is lower, probability reduces accordingly. Finally, I used NumPy random choice to assign either failure or healthy status. This probabilistic approach makes the dataset more realistic instead of deterministic. Next, we will go to the train model. After creation of the dataset, I trained a random forest classifier. First, I separated feature and a target variable. So, like, then I performed the train test split in the ratio of 80% in training and 20% in testing. I selected random forest because it is powerful for tabular data and can handle nonlinear relationships. I use the following hyperparameters. Let me show you. So this is the estimators 500. To improve stability, I just done it, and the maximum depth is 20 to prevent overfitting, and class weight set to balanced to handle class imbalance. After training, instead of directly predicting output, I used predict underscore proba here as you could see. So this gives the probability of failure instead of a binary output. Next, if I come here, this is threshold, custom threshold. Instead of using default as a zero point 0.5, I used here 0.40. There is a reason why I have used this. Like in networking, missing a failure is more critical than a false alarm. So lowering the threshold increases sensitivity and helps detect failures earlier. I evaluated the model using accuracy score, classification, and confusion matrix. So accuracy shows overall performance, and classification report gives precision, recall, and F1 score. Recall is very important here because it measures how well failures are detected. Next, confusion matrix helps identify false negatives which are critical in this project. Next, feature importance which I have given. So I extracted feature importance from the model to understand which parameters influence failure most. This confirms that the model is learning meaningful patterns. Next is for, let's go with the predictions. So predict.py. Finally, I tested the model using a sample input. The model calculates the probability and compares it with the threshold. If probability is greater than or equal to 40%, it predicts failure. Otherwise, it predicts healthy. As you can see here, failure likely, prediction, and print healthy. This allows real-time prediction for of network issues. So the conclusion is like in this project, I just combined networking domain knowledge with machine learning techniques. Instead of relying on only algorithms, I design realistic data using risk scoring and probabilistic modeling. This makes the system more practical and closer to the real world. Thanks, everyone.